Hello students. Today we will discuss one another important name reaction of aldehydes and ketones, and it is Wolf-Kishner reduction. In Wolf-Kishner reduction, the aldehydes or ketones both they gets reduced to their corresponding hydrocarbons. When they are heated with approximately at 200 degrees Celsius, heated with hydrazine, and strong alkali or strong base, like we may take here NaOH, KOH, or potassium tertiary butoxide. So this reaction is known as Wolf-Kishner reaction. Means we can say that the reduction of aldehydes and ketones to corresponding hydrocarbons with the help of hydrazine and strong base in presence of a high boiling solvent like ethylene glycol. So the reaction is known as Wolf-Kishner reduction. We may write the reaction in this manner. See, let this is our aldehyde, and when it is treated with hydrazine, hydrazine is NH2. So here these both the hydrogens comes out with the oxygen of the carbonyl group in the form of water, and here we will get a compound. See, in the here carbon has broken two bonds, nitrogen is breaking two bonds, so double bond will form in between the carbon and nitrogen, and over this nitrogen there are two hydrogens. See, the species where there is a double bond between carbon and nitrogen, and over nitrogen it is NH2 or derivative of NH2 is there. So such species is called hydrazone. Because this hydrazone is formed from aldehyde, it is aldehyde hydrazone. If our aldehyde is acetaldehyde, our hydrazone will be acetaldehyde hydrazone. If our here in place of aldehyde we are taking acetone, so hydrazone will be acetone hydrazone. Now here what happens, as we are taking a strong base also, O, and we are heating it at high temperature, and ethylene glycol is used here as a solvent. So what happens here, the OH minus ion furnished by the KOH will remove this H hydrogen which remains linked over the nitrogen, and these two hydrogen shifted over the carbon of CN bond, and this nitrogen sets free as N2 molecule. See, nitrogen comes out as nitrogen molecule, and these two hydrogens shifted over the carbon, and in this way we get here hydrocarbon. As I'm taking here aliphatic aldehyde, so here I'm getting a alkane. In case if here, suppose I'm taking ketone, this one is cyclopentanone and is treated with hydrazine. Same, these two hydrogens sets free along with the oxygen of the ketone in the form of water, and here ring has broken two bonds, nitrogen has broken two bonds, double bond will form in between them, and over this nitrogen there is a NH2. Again, this one is hydrazone because it is obtained from the cyclopentanone. So the hydrazone is cyclopentanone hydrazone. Now the strong base KOH is taken here, and this KOH will remove these two active hydrogens. Active hydrogens means the hydrogens remains linked with the more electronegative atom. See, these two electropositive hydrogens will be removed and nitrogen molecule sets free, and the two hydrogens which are removed from the nitrogen will form bond with the carbon, and nitrogen molecule sets free. We obtain here cyclopentanone. Pentane. Is it clear? Now we'll discuss that how the reaction occurs, means the mechanism of the reaction. See, this is our aldehyde, and it reacts with hydrazine, one of the reactant. Here these two hydrogens comes out with this oxygen. See, this is a reaction, this is a type of reaction. It is a nucleophilic addition followed by elimination of water type of reaction. Your water molecule sets free, and as a result the double bond will form in between the carbon and nitrogen, as both are breaking two bonds, and your nitrogen, and this nitrogen is having a two hydrogens. As we know, the nitrogen is third most electronegative element, so these hydrogens are having partial electropositive charge. This one is hydrazone. As it is obtained from aldehydes, so we may write it is an aldehyde hydrazone. Now what happens here? The OH minus ion, which is furnished by the KOH, which is taken here along with the hydrazine, in presence of solvent, it is ethylene glycol, which is high boiling solvent, is taken here. So this OH minus will remove or abstract this hydrogen as a proton, means the two electrons of this NH bond shifted over nitrogen, and the H plus will come out with the OH minus in the form of water. Here you will get R, C, H. Your double bond is still there. Nitrogen is having a lone pair, and over this nitrogen now there will be only one hydrogen. See, one electron pair was already nitrogen was having, and the 2 electrons of this NH bond comes over the nitrogen. That's why it will become negative charged. Now see here. Here the lone pair of the nitrogen is conjugation with the double bond, and therefore resonance will occur. These extra electrons will shift in between the two nitrogen atoms, and these electrons of the pi bond will shift over the carbon. We'll get another resonating structure here. Now, as the 2 electrons comes over the carbon, so will become now negative charged, and single bond will remain now in between the carbon and nitrogen. And here, as the 2 electrons of nitrogen comes in between 2 nitrogen, so double bond will form here. Over nitrogen only one lone pair left, and over nitrogen there's the hydrogen. Now this molecule or anion thus obtained, this anion, this will abstract proton. It will remove a proton from water. See, water is here. So we'll remove a proton. H plus will taken by the removed by this negatively charged carbon, and here the OH minus ion sets free, and the proton will form bond with this electronegative carbon, and you will get RCH. Here hydrogen will form bond with this carbon, and now nitrogen, that's the double bond, another nitrogen, and this nitrogen is the hydrogen. Now again the OH minus ion. See here the one OH minus ion is consumed, and in this step the one OH minus ion is reduced. Means still there's the concentration of the OH minus ion. So the OH minus ion again furnished by the alkali, a strong base, that one will remove the another electropositive or active hydrogen. See what happens? Both the electron of this NH bond will shift over the nitrogen, and the H will come out in the form of H plus, will combine to the OH minus and sets free as water. Here it's R, C and H. Here N, nitrogen is having lone pair, there's a double bond between the two nitrogens, and this nitrogen was already having one pair of electrons, and the 2 electrons of this NH bond comes over this nitrogen. That's why it will become now negative charged. This type of anion will be obtained. Now, in order to compensate or minimize the stress, see this nitrogen will shift its electron pair. One of the, as it is now, it is having 2 electron pairs. 1 electron pair will be shifted in between the 2 nitrogens, and at the same time the electron pair of the carbon nitrogen bond shifted over the carbon. And now when the 2 electrons comes in between the 2 nitrogen atoms, so N2 molecules sets free, and here you will get a carb anion. As the 2 electrons will come over the carbon, so carbon will become now negatively charged, and we will get a carb anion. Now this carb anion, this will abstract a proton from water. So this will remove a proton from water. See, this is water. The H plus will be removed by this carbon ion, and OH minus ion gets free. See, OH minus is taken, one OH minus is taken here, that will free here in the last step, and then the proton which was abstracted from the water will form bond with a electronegative carbon, and in this way here I will get a hydrocarbon. As I am taking aliphatic aldehyde, so I will get a alkane. So is it clear? This was the mechanism of the Wolf-Kishner reduction reaction. Okay.